Now there is another question. Suppose this is water. You can say it is a lake in which water is filled, and this is unpolluted water, clear water. So we can see inside the water a refractive index of water is 4/3, that is given, and this is bottom of the lake. This lake is 2 meters deep, and here there is a pole. Here there is a pole, and that is like this. There is a pole 2 meters in the lake and 1 meter above this lake. That is also given. This is horizon. Sun rays falling on this post. Sun ray falling on the pole at angle 30 degree from horizon, that is given. This is sun. Shadow of this part of pole cast on the upper surface of lake up to here, and then this ray goes into water, so it will bend towards normal. So this is the length of shadow of this pole at bottom of lake. We have to find this. So let this point be A, B, C, D, E, F. This angle 30 degree, this angle is also 30 degree. This is normal and this is incident ray, so here this angle is 60 degree. This angle, let it be R. So if I use Snell's law here at point D, then it is 1 air into sine 60 is equal to mu water, that is 4/3 into sine R. So it is √3/2 is equal to 4/3 into sine R. So it is 3√3 divided by 8 is sine R. So from this triangle CBD, from triangle CBD, triangle CBD, this angle is 30 degree. If I use tan 30, it is CB upon DB, and CB is 1, so DB is 1 upon tan 30, that is 1 upon √3, so it is √3. So this distance is √3 meter. So this distance is also √3 meter. Now this distance we have to find. We know sine R. So what is cos R? It is 1 minus sine square R square root. So square root of 1 minus square of sine R, square of this. So 9 into 3 upon 64. So it is 64 minus 27 upon 64. It is √37 upon 8. This is cos R. So what is tan r? Sin r upon cos r, that is 3 root 3 by 8 upon cos r, root 37 upon 8, so 8 cancel, so it is 3 root 3 divided by root 37. So this is tan r. Now in this right angle triangle DFE, in right angle triangle DFE, tan r is perpendicular, that is FE upon base, that is DE. So 3 root 3 divided by root 37 is equal to FE upon 2, because D is 2 is given, this is 2. So F E 6 root 3 upon root 37. So length of shadow of pole on bottom of lake is AF. So AE plus FE. Length of shadow on bottom is equal to L is equal to AE plus EF. AE is root 3 plus EF 6 root 3 upon root 37. So this is your answer. So this is length of shadow of this pole on bottom. So that is how we are going to solve it. Lateral shift. Suppose glass slab is there, its refractive index is mu and this is air. Ray is incident like this. At angle I. Thickness of this glass slab is T. Then after refraction it follow path like this. It will bend towards normal because it is entering in denser medium. This was actual path. This was actual path, but it is now going, this is the path, original direction, but now light is going like this. It will come out of glass at this point. So if this angle is R, this angle is also R. These two are parallel line and it is transversal. This surface parallel, this medium same, so this angle and this angle will be same, already proved. Now this is perpendicular shift of the ray that should have gone like this, but it is actually going from here. So this is called lateral shift perpendicular to its propagation. So if this point is A, this point is B, this point is C, this point is D, then DC is called lateral shift, that we have to calculate. This angle will be I minus R, angle of deviation. So lateral shift here means CD, and let it be L. So in triangle, right angle triangle ABC, if I use cos R, it is base upon perpendicular, so it is base upon hypotenuse, so AB upon AC, AB upon AC. So from here, what is AC? It is AB upon cos R, and AB is nothing but thickness of this glass slab, so it is T upon cos R. This is AC. Now in triangle ACD, in triangle ACD, if I use sine I minus R, so sine theta is perpendicular upon hypotenuse. This is perpendicular and this is hypotenuse, and this is angle. So perpendicular is CD upon AC, hypotenuse. So CD will be equal to AC into sine I minus R, and AC we have already calculated. So from here, from equation 1, if you put value of AC here, you get CD. So it is T upon cos R into sine I minus R. So this is formula for lateral shift. CD is called lateral shift. If angles are small, means if incident ray is normal or near normal, you can say, then angles are small. So in case of a small angle, if angles are small, then using here Snell's law, 1 into sine I is equal to mu into sine R. If angle are small, we can write I is equal to mu R, and then CD will be equal to T upon 1. If angle is small, then cos theta is 1. So here R is small, therefore cos R is 1, and sin theta is theta. So sin I minus R is simply I minus R. So CD will be equal to T. At place of I, we can write mu R minus R. So CD will be equal to T mu minus 1 into R. R is angle of refraction. At place of R, you can write I upon mu, because generally angle of incidence is given in this case. So CD is equal to T mu minus 1 into I upon mu. So CD is T 1 minus 1 upon mu into I. So this is lateral shift when ray falls normally. So in case of normal view, lateral shift is this. General formula of lateral shift is this. You may use identity here, sin A minus B. So that is lateral shift. Now one theoretical question here, suppose this is a glass slab. And here you incident white light. Then different color will be refracted at different angles, because you know sin I upon sin R is, in this case it is mu. If mu is greater, then this ratio is greater. It means sin R is lesser, it means R is lesser. So if mu is greater, R is lesser, and mu is greater for violet color, because mu and wavelength product constant. So mu inversely proportional to wavelength. Lesser is the wavelength, more is the mu. So wavelength for blue color or violet color is less, hence mu for violet or blue color is more. So if this is more, this will be small. If this is more, this will be small. So for blue color, R will be small, so it will be somewhere here, and for red color it will be large. So here you are going to see red color, here you are going to see blue color or violet color, and all other color will be in between these two. So when a white light is incident here blue and red color appeared simultaneously, but they appears at different places, because angle of refraction is different for different colors. In this case, mu is greater, so this ratio should be greater. Sin I will be same for all. So if this ratio is to be increased, this should be decreased. So sin R should be less, hence R should be less, hence ray should be bended towards normal more. So blue color light will come at this position, yellow at this position, but they appear simultaneously. Because the speed of different color light in this is different, and therefore they have to travel different distances. Red travel faster than blue, so red has to travel larger distance as compared to blue, so that they take equal time to go from point A to this point. Now if this is a glass slab, and white light is incident like this, now rays will not deviate from its path, so they have to travel this much distance, thickness of glass slab, to come out of this glass slab. Now you know red travels faster than blue, so first you are going to see red color. First red color appears, and in last violet or blue color, in last, and finally white, because when all color of light will go from here to here, it appears right. So for fraction of second you are going to see first a red spot, it become yellow, and finally it become blue, and then it become blue, and finally it become white. So here if you incident white light like this, then for the first time which color come on this side? Red, and in last blue, and finally all color. When all color has come here, white start appearing white, light start appearing white. So that is the some theoretical question you must keep in your mind.